All right, guys, so this is lesson 3, properties of real numbers. So this is the beginning. So in the warm-up here, what I would do is stop the video, pause it, and try them, and kind of see what you notice about your answers for 1 and 2, and then again for 3 and 4. Okay, so if you paused it, you should have noticed that for number 1, 5 plus 10, you get 15. And then for 10 plus 5, it's the same answer, 15. So what do you notice about your answers? I kind of just said it. They are the same. So if you look at numbers 1 and 2, all that really changed here is the position of my 5 and my 10. My answer stayed the same, but the position of my numbers changed. So if we bounce over now to number 3, 7 times 3, we get an answer of 21. And then 3 times 7 should be 21 also. So what do we notice about those answers is that, again, they are the same. So if we notice the difference between 3 and 4, again, all that changed was the position of the numbers, 7 and 3. Then it's 3 and 7. So this kind of leads us into our first property, where if you look, we use multiplication and addition, and my answers did not change. Only the position of my numbers changed. So with that said, it leads us into this commutative property of addition and multiplication, which by definition is that you can add or multiply numbers in any order. So it does not matter the order of the numbers. Rather, you can do them any way you want. Your answer will still be the same. So the commutative property starts with CO. So if you look at the word commutative, we have a CO in the beginning. So it starts with this CO, which means change order. And that's how I remember this. So if you look at an equation and you tell me that it's just changing order, then it's the commutative property, CO, change order. So one another way to think about this is that if you think about commuting from one location to another, so think about yourselves when you leave your home and you commute to school. When school is over, you then go from school back to home, right? It's still the same commute in terms of going from one place to the other, right? But you're reversing it. It's still the same, but you're just changing it. So if we look at examples here, these deal with 3 terms. So we're going to change at least one of those terms. So 4 plus 2 plus 5. If I make this 2 plus 4, plus 5, I changed the order of the 2 and the 4. So if you look, I changed the 2 and the 4, and I switched them around. Now, if I was to take my calculator and put them both in, both sides, I should get the same answer. So if I do 4 plus 2 plus 5, I get 11. And if I do the other side, 2 plus 4 plus 5, I still get 11. So in this case, I get 11 equal to 11. So this statement is always going to be true regardless of the order of the numbers. So again, same thing for B. Let's say for B, we change the order of 6 and 8. So we make it 12 times 8 times 6. And again, I left a little space there because I'm just going to draw in the multiplication with a dot, right? So I just switched again the order of my 8 and 6. So I'm changing order. And both sides should give me the same answer. So 12 times 6 times 8 is 576. And then 12 times 8 times 6 gives me also 576. Therefore, both sides are equal to each other and order did not matter. Okay, and then the next one, I could change the order inside the parentheses. So let's just say I changed it and made it 3 plus 4 plus 10. So now what I did was I changed the order of my 4 and 3 and made it 3 plus 4. Again, I could prove this in the calculator. Parentheses 4 plus 3 plus 10 gives me 17. And then parentheses 3 plus 4 plus 10 is also 17. So they're again equal to each other, proving that my order does not matter. So that is our commutative property. Notice that for the commutative property, that this is only going to work for addition and multiplication. It will not work for any other operations like subtraction or division. Okay, so our second property here that we're going to discuss is the associative property of addition and multiplication. So the associative property, I like to kind of relate to friends. So let's just say we have 3 friends, right? I'm going to call my 3 friends Al, Bob, and CJ, right? And Al, Bob, and CJ, they're all best friends, and they go through their day, right? And maybe they see each other sometimes, but they're all still friends. If, let's say, first period, Al and Bob have math together, and CJ's all alone in English. But now, second period, Bob and CJ have gym together. And poor Al, he's all in science by himself, right? So they're still friends. They're associating differently throughout the day. So basically, or I should say, they're grouped differently throughout the day. So the definition of the associative property says that you can add or multiply in different groups. So basically, it doesn't matter how I group my terms. In the end, they're still the same. They're still equal. So association are groups or grouped. So here, when we look at this example, one of the big things to remember with association is that order does not change. That's important because in the commutative property, order changes. In the associative property, my order stays the same. So when I rewrite this, it will be 3 times 6 times 4 still. That won't change, right? The fact that I'm multiplying these 3 numbers in that specific order does not change. What will change is the fact that in the first part of this, 3 and 6 are grouped together. And in the second part, we're going to change it and make it 6 and 4 grouped together. Okay? Now, what we should be able to prove is the fact that the answer will still be the same, regardless of where that grouping happens. So if I go to my calculator now, and I do 3 times 6 in the parenthesis times 4 on the outside, I get 72. And then for the other side, 3 times 6 times 4, I should still get 72, which I do. So then we proved the fact that when I move the parentheses and I change the grouping, my answer doesn't change. So now in the second one, again, we should be observing that my order would remain the same. So it would go 9, 5, 12. In that first part, the 9 and the 5 are grouped together, right? And we're going to change it so that the 5 and the 12 are grouped together. Now again, when I put this in my calculator, I should notice that my answer does not change. So we get 26 on the left side. And then if we move those parentheses and do the same thing, we're going to get 26 on the right side. So again, we just proved this to be true for addition. So again, this will only work for addition and multiplication. If I try to change it to subtraction or division, it's not going to work. Also notice that in both A and B, it was all multiplication or all addition. That also has to stay the same. Okay, so that's our second property. The third property is the distributive property, which is probably the most common one that we're going to use this year and that you kind of have to be able to apply to problems. So the distributive property says that each element inside the parentheses gets multiplied. So you guys would actually have to write this multiplied by the element outside. So if we just jump kind of to the examples, the distributive property says that the 3 and the 6 that are inside the parentheses are going to get multiplied by this 4 that's on the outside. So what would happen is we would take that 4 and we would multiply it by the 3. So I'm going to write the work to the right. So we want to do 4 times 3. Let me just make that neater for you guys. So you would want to do 4 times 3, and then you're going to multiply or distribute it to the 6. So it would be 4 times 6. So 4 times 3 is 12. Plus 4 times 6 is 24. So if we add 12 plus 24, we get 36, which would be our final answer. And this is really hard to see, guys, so I'm just going to kind of type it in after that. I want you guys to be able to read this. So this would be an answer of 12, and this would give me an answer of 24. And when we add them together, we would get the 36 as an answer. Okay, so now if we do the same thing for the next one, we're doing 2 times 7. So we get 2 times 7, and then we're going to do 2 times 9. So 2 times 9. Okay, 2 times 7 would give us 14, plus 2 times 9 would be 18. Okay, if I add those together, 14 plus 18 is equal to 32. And notice I'm able to add these together, the 12, the 24, and the 14 and the 18, because they're like terms. If I go look at number or letter C now, right, if I'm going to distribute, it would be me taking this 3 and multiplying it by y. So that's 3 times y. And then taking 3 and multiplying it by 5. So 3 times 5. So now when I look at this, 3 times y, I can't really do anything with that. So it remains 3y. 3 times 5 is a positive 15. And now I cannot combine anything. So my final answer just kind of stays exactly the way it's written, 3y plus 15. So that's our distributive property. We're going to do a whole worksheet on this. We're going to look at it more, the distributive property, because it's super, super important. So if we move on from that, we're looking next at our identity properties. And I always think of identity as who you are, right? You can cut your hair, you could dye your hair, you could wear, different clothes one day, but you're still you. Like I could cut my hair really short. I'm still Mrs. DeCristo. I'm not going to change who I am. It's my identity. So the identity property of addition and multiplication says that for both multiplication and addition, there's one number, only one number that I could take, and it's not going to change the number I started with, right? So these elements, they're called identities. Okay, so what is the identity element for addition? In other words, what number can we add to a number without changing it? So let's just say I started with the number 2. What could I add to 2 to still get an answer of 2 when I'm done? So think about it. What number, when I add, is not going to change my answer? So if you thought about it for a second there, 0, if you take 0 and you add it to 2, you're still going to end up with 2 as an answer. So what's my identity element for addition? It's 0, right? You can take 0, add it to the number, any number, and you'll still end up with the same identity back. So now let's think about it for multiplication. What number, if I start with 2 again, could I multiply by and again still end up with 2? So obviously it's not 0, because if I multiplied 2 by 0, I would get 0. So think about a number, take a second, and I'll keep quiet. What could you multiply by that would keep that answer 2? Okay, so you should have kind of taken a second and thought about it, and it would be number 1, right? If I do 2 times 1, I still end up with 2 as an answer. So my identity element for multiplication is 1. I could multiply any number by 1, and I'll still get the same answer back. The identity doesn't change. So those are your identity properties. You keep the number the same. For addition, you would add 0, and for multiplication, you would multiply 1. Okay, the next one is called the inverse property, and I like to think of the word inverse as opposite. Okay, they kind of mean the same thing, in my opinion. Well, they do mean the same thing. So the inverse property of addition and multiplication states that when a number is combined with its inverse or opposite, here's that other word, opposite, right? So when it's combined with its opposite, it is equal to its identity. So when I combine them, when I'm adding, I should be equal to 0, because that's the identity for adding. And when I multiply, I should end up with something like 1, because that's its identity. So negative A is said to be the additive inverse of positive A. So a negative A and a positive A, those are inverses. Negative A and positive A. They're opposites, they're inverses, and when I add them, I get an answer of 0. Now, with multiplication, it's a little bit harder. So we have 1 over A is considered the multiplicative inverse of just A. Now, how is that possible? Well, when we take the opposite, when we're multiplying, what we're technically doing is we are taking the reciprocal, which just means that you are flipping the fraction. Well, you might be thinking in your head, well, A is not a fraction. What is she even talking about? The letter A is not a fraction, right? Well, technically, I can take the number A, the letter A, right? And I could put it over 1. So if I take A and I put it over 1, I've created a fraction. Now, I could do that with any number. I could take the number 5 and put it over 1, and now it's a fraction. So if I was to flip A and 1, I would end up with 1 over A. So those are inverses, because when I multiply them together, A times 1 over A, I would equal 1. This is probably the hardest property to remember because it's new, it's different, right? If you think of the word inverse as opposite, it might help. So if we look at the examples, 5 plus what is equal to 0? So think about it as what's the opposite? Well, positive 5, the opposite of that would be negative 5. Here, I'm giving you a fraction 1 over 4, and I want to know what's the opposite. So this is one where you would have to flip the fraction. So 1 over 4 would become 4 over 1, which is basically the same thing as just 4, right? You can write it either way, 1 over 4 or just 4. And when you multiply those, you get 1 as an answer. Take a second, make sure you wrote down all those side notes that I just made. They will definitely help you. If not, you can always look at the answer key online and kind of get it from there. Okay, so just a brief summary now of these properties that I kind of just went through. This is kind of a good little like cheat sheet here to have because you can always refer back to it. So the commutative property of addition says, or both community properties of addition and multiplication say that you're changing the order, right? Your change order for those properties. My associative property says that I am changing the grouping. My distributive property says that I'm taking my term on the outside and I am multiplying it by what's on the inside. My identity properties say that my element or my starting term do not change. My starting term does not change. That's what my identity properties say. My inverse properties talk about adding or multiplying the opposite. So remember, for addition or addition, it would be the negative or the positive, depending on what it is. And then for multiplication, you're taking the reciprocal. You're flipping the fraction. So again, if we started with a 2, remember it's not a fraction, but we could always take it and put it over 1 and then flip it to get 1 over 2. So again, this is kind of a good chart to have and revert back to. Maybe if you want to add the side notes like I did, it will help you kind of be able to flip back and look and, have them right in front of you when you're working on something. Okay, so now what we're going to do is we're going to just go through some of these properties here. So name the property that's illustrated with each exercise. So here, what's happening? -2 plus 7 equals 7 plus -2. So right away when I look at this, I could see that my order is changing, right? The 7 and the -2 flip-flopped. So when that happens, or when we change order, okay, change order, CO, that is my commutative property, and it's of addition because there's addition in between my two numbers. Okay, number 2, we have 3 plus 5 plus 2 is equal to 5 plus 2 plus 3. So what happened here? In the beginning of this one, I have my 3 in the front, and then it moves and goes to the back, right? So the order again changed, which again is my commutative property of addition because there's addition in between. Okay, here we have x equals 1 times x. So what's happening here is the fact that we are ending with an x or starting with an x, however you want to look at it, and we're multiplying by the same term x by 1, and it's not changing, right? My answer is the same as my original. So the identity of this did not change. So this is the identity property of multiplication because we are multiplying here. Okay, in this one here, x times y equals y times x. Well, x was first on this side, right? And then it switched over and became my last term on the right. So we changed the order. Commutative, as soon as we can say that, property. And now what operation is technically in between my x and my y? Okay, when you don't see an operation, it is multiplication. And remember, it can only be addition or multiplication. So if you don't see addition, then it has to be multiplication. Okay, here we're starting with a -9. We're adding a +9. So we're adding the opposite. And as soon as I say opposite, we should think of that word inverse. So this is going to be the inverse property. and it's going to be of addition because we are adding in the problem. Okay, number 6, I start off with an element on the outside of the parenthesis, and what's happening is I eliminated my parentheses, right? So what I did was I distributed and did 5 times 10, and then I did 5 times 2, right? And what happened is I got 50 plus 10. So what just happened was the distributive property, and I kind of said it as I was working. Okay, so again, if you're just watching, make sure you go back. You can print the notes. You can just have them, fill them in, whatever works for you guys. Sometimes it is just more helpful to watch for the first time. So if we keep going, we have more. We have x equals x plus 0. So what's happening here is I'm adding 0 to a term, and I get the same answer back. So it might help if we rewrite this the other way, meaning we do x plus 0 is equal to x. I think it's just more helpful. So you can see that you're adding 0 and your identity or your element doesn't change. So that's going to be your identity property of, we are adding addition. Okay, here, number 8, we're doing 5 times 3 equals 3 times 5. So what happened here is that my order switched, right? It's 5 times 3 here, but then it's 3 times 5. Well, again, my order changed. We changed order. That is going to be the commutative property of, now we're multiplying, so multiplication. Okay, in number 9, we start with these parentheses and we end up without them. So we have to look, how did we do that? Well, what we did was we took the element on the outside, that 4, and we multiplied it onto the inside, because 4 times 5 is 20, and 4 times negative 2 is negative 8. So when you're doing that, you're getting rid of the element on the outside. That's called the distributive property. So notice that these are being repeated, these properties. I want you to kind of see them different ways. Here we have 1 over 9 times 9, and it's equal to 1. So again, this is kind of hard to see, but if I go like this and make this a fraction, now these are what we call reciprocals. And reciprocals, when we multiply, right, we're multiplying, are opposites, or what I like to say, inverses. So this is the inverse property of multiplication. Okay, so number 11, when we look at this one, we have 3 plus 5 plus 7 is equal to 7 plus 5 plus 3. So my 5 is still in the middle, right? So what really happened was we changed the position of the 7 and the 3. Again, I used the word from the definition. I changed the position or the order. So that's the commutative property, and it's of addition because we have addition in the middle of all 3 terms. Okay, and then the next one, number 12, says 7 plus a negative 3 is equal to a negative 3 plus a 7. So here, again, we changed the order of my numbers. So again, that is going to be the commutative property of, again, addition. There's addition in between them. Okay, so make sure again that you're writing these down, the answers. If not, they're going to be on the answer key. Okay, so these are the Regents questions that go with this. These are, some of them are a little bit harder than others. Some of them are pretty straightforward. But the first one says the statement 2 plus 0 equals 2 is an example of the use of which property of real numbers. So what I would do here is kind of focus on the actual equation. So the 2 plus 0 equals 0, right? That's what we want to focus on right now. we want to know what property is that. So what's happening is we're starting with an element of 2 or a term of 2, and we're adding 0, and we're getting back the same term. So the identity of it is staying the same. We are also adding, so it would be number 2, the additive identity property. Okay, number 2, Tori computes the value of 8 times 95 in her head by thinking of 8 and then parentheses 100 minus 5 equals 8 times 100 and then minus 8 times 5. So which property did she use here? So what she's doing is she's taking the element on the outside, that term on the outside, that 8, and she's multiplying it by each term on the inside. So the property being used is the distributive property. Okay, number 3, which property of real numbers is illustrated by the equation 52 plus parentheses 27 plus 36 equals parentheses 52 plus 27 plus 36. So the order of my numbers remain the same. So here we have order staying the same, 52, 27, 36. So order stayed the same. And what happened is that the parentheses shifted or the group changed. So if my grouping changes, the property being used is my associative property. Who they're associating with, remember the group of friends, is what's changing. Which equation for number 4 is an example of the use of the associative? So that's the same thing, associative. We want to look for the grouping changing. So we want order to stay the same, but we want the grouping to change. So when we look at our 4 answer choices, choice 1, my order changed. X plus 7 equals 7 plus X. For number 2, we have 3 on the outside, and then it's being distributed into the parentheses. So that's a distributive property. Number 3, we have X plus Y in parentheses plus 3. And then we have X plus parentheses Y plus 3. So when I read that, the order of my terms stayed the same. X, Y, 3, X, Y, 3. But what's grouped together changed. On the left side, X and Y are grouped together. And on the right side, Y and 3 are grouped together. So that's the grouping. We're looking for something that keeps that original element the same. And remember, we're multiplying. So because it used the word multiplying, anything that has, like number 1, addition is out. Number 2 is subtraction, it's out. So the last 2 do have multiplication, and we're looking for the property where we start with the original element and we end or answer with the exact same thing. So in choice 3, we start with X, but we end or equal 1. So that's not an identity property. In choice 4, we start with X, we multiply by 1, and we end up back with X. So the identity does not change, making this my identity element property of multiplication. And the last one talks about which is the distributive. So I like to think of distributive, guys, as multiplication. It's just a nice, easy way to remember this. Multiplication is occurring. So in choice 1, we have 5 parentheses A plus B, and then we end up with 5A plus 5B. So the element on the outside here of 5 gets multiplied by each term on the inside, A and B. That is an example of the distributive property, which means choice 1 is my answer here. In choice 2, you'll notice A and B are switching places, and in B, the grouping is changing. And in 4, we're talking about the identity staying the same. A is equal to A. So those are some examples from old Regents exams. And this is basically just a review, again, like exit ticket thing. So if you want to pause and see if you can come up with an example of each one, it doesn't matter if it's multiplication or addition for all of these. Just come up with one at least. See if you can test yourself, quiz yourself. So pause it and try it. Okay, so if you tried it at this point, you're going to type in your example. So I'm going to draw it in. So commutative property, I'm going to use addition here, and I'm going to say 2 plus 3 is equal to 3 plus 2. So remember in this example, my order changes, right? That's my commutative. We change order. The next one, associative. We have 3 things and they are changing grouping. So our grouping is what changes here. So grouping changes. So if we have 2, my stylus is just not really cooperating today. So I'll do it with the text for you so that it's nice and clear. So if I have 2 plus 3 plus 5, and that's equal to 2 plus 3 plus 5, notice that my order did not change here, right? 2, 3, 5, 2, 3, 5, right? What's going to change is what's grouped. So in the first or the left side, the 2 and the 3 can be grouped together. And on the right side, I'm going to group my 3 and my 5. Now, again, you might have a different example. Just make sure your order stays the same, but your parentheses move and change the grouping. For an example of the distributive property, I'm going to do 2 parentheses, and I'm going to do 3x plus 4. And I want to distribute the outside number 2 to each term on the inside. So 2 times 3 would be 6, and I have to carry that x with it. And then we're going to do 2 times 4, which would give us 8. So we distributed there. Okay, inverse. Remember what that word, I always like to remember the word inverse as opposite. And for me, this is a nice easy one if I think of the addition. I'm going to show you both just because this one is definitely a little bit harder to understand. So if we use it with addition, if I start with, let's say, let's do 3. Whoop. Let's do 3 plus a negative 3. Those are opposites and they equal 0, right? If we did multiplication, and let's say I started with 2/3, right? If I multiply by the inverse or the opposite, I would take the reciprocal and flip it and make it 3/2, and that would give me 1. So that's for addition and multiplication. I gave you both there. The identity property just says that if I start with an element, I want to end with that same element. So for example, if I start with -7 and I add something to -7, I want to end up back with -7. The only term that lets me do that is 0. So if I add 0 to any term, I end up back with the identical answer. Okay, so with that said, guys, that's the end of the first part to this lesson. If you have any questions, you can always email